Hi everybody. So we're going to keep talking about inequalities. We're going to talk about rational inequalities. This is very, very similar to what we did in the previous video where we talked about polynomial inequalities. So if you haven't watched that, I do encourage you to watch that one first. It kind of sets the scene for this. Okay, so we have the exact same methods, okay, for this as we did for the previous one with solving polynomial inequalities. Okay, you can solve graphically, okay, or you can solve algebraically. So we're going to start with solving graphically, okay? So the first thing we're going to do is move all terms to one side. Okay, we were doing this with polynomial inequalities too. We were just calling it put it in standard form because polynomials have a standardized form. Rational functions don't really have a standardized form, so we're just going to move all the terms to one side. Then we're going to graph, okay? And at this point, our only method for graphing is to use base graphs and transformations. Okay, later in the class we'll talk about how to graph all sorts of rational functions, but at this point we can only graph rational functions using the base graphs and transformations. So that's what we're going to do. Okay, and then we're going to use the inequality use the graph to solve inequality. Okay, and then we're going to write our answer in interval notation. Okay, I said this last time, but I'll say it again. For most inequalities, interval notation is the best. You can also use what's called set notation. So if you know set notation, you're welcome to use that. But interval notation is what we're going to use. Okay. All right. So let's look at our first example. Okay. So I did pre-make the graphs again. Okay. So we're looking at this 3 over x plus 2 minus 1 is less than or equal to 0. Okay. Now, we have already done step 1 because all the terms are on the left side and you're comparing the function to 0. That's why you want to move everything to one side, is because it's easy to compare the function to 0. Okay, so we're going to do that. All right, and then we're going to graph. So like I said, I already did the graph. Okay, so the transformations were plus 2 moves it left 2. Okay, 3 stretches it vertically times 3, and minus 1 moves it down 1. Okay, so you can see this graph, and I've marked the key points here and here, and I've labeled them so you can be sure your graph has the same key points. Okay, so now we're looking for where the graph is less than or equal to 0. Okay, so remember, when we're asking about less than or equal to 0, we're asking about the y values being less than or equal to 0. Okay, so that's when we're below the x-axis. So you'll notice this whole branch of the graph is below the x-axis. Okay, and then there's an additional part starting here and moving this way. Okay, all right, so I also want to remind you that when we write our answer is in terms of x values. Okay, so they're giving you the y values, you're answering the corresponding x values. Okay, so the x values, you can see this pointing to the left, so we're going to go negative infinity up to, okay, this line is at negative 2. Okay, and we're not going to include negative 2 because we know that the graph doesn't ever touch this line. Okay, then we're going to keep going. We look, the values start here at 1. Okay, and because it's less than or equal to, we are going to include the value 1. Okay, and the values continue to the right, so we're going to go off to infinity. Okay, and we're going to join those two intervals with the union. All right. So I wanted to highlight one of the differences between this and the polynomial graphing. Okay, you can see that we use parentheses here even though we have less than or equal to, okay, and it's because we're not talking about an x-intercept, right? We're talking about this part of the graph where it just continues down but never actually reaches that value. So that's why we need the -2. Okay, if in terms of domain and range, we would say that -2 is not in the domain of this function, right? You can't plug in -2 here, all right? So that's why we need parentheses instead of brackets, even though we're talking about less than or equal to. All right, so let's look at part B of this example. All right. Okay, so here we have 1 over x minus 3 squared minus 4, or less than 4, okay? So the first thing we want to do is move everything to one side so that we're comparing the function to 0, okay? So I'm going to do that now. Okay, so I'm going to subtract 4 from both sides. Okay, and now I'm going to graph my function. So we know that the -3 is going to move it right 3, okay? And this -4 is going to move the function down 4. Okay, so here's our final graph. You can see here's my 2 key points. Okay, and I have these key points labeled for you guys. Okay, all right. So now we're looking at where this is less than 0, okay? So we're looking for y values less than 0, okay? Now, I'm going to mark the part of my graph where it's less than 0, so certainly this part is less than 0 up to this point, but not including the x-intercept, okay? And same here, starting at the x-intercept, but not including it, and going off to the right, okay? Now, this shows kind of one of the inherent problems with this method, okay? This is between 2 and 3, but we don't really know exactly what this value is, okay? So if we were doing this algebraically, we would be able to figure that out, but because we're doing this graphically, we're just going to estimate, okay? So we're going to start by showing that this goes infinitely to the left, okay? So -infinity up to whatever we think this point is here, okay? So for me, between 2 and 3 somewhere, maybe 2.5. Okay, and again, we're not going to be including it because it's strictly less than. Okay, then we're going to start over at this point. Okay, so to be symmetrical, because this is between 3 and 4, we're going to say this is 3.5. Okay, we're not including it because it's strictly less than. And then it continues to the right, so this is going to go off to infinity. Okay, and then we're going to combine our two intervals using the union. All right, so now that we've looked at how to do this graphically and maybe some of the issues with that concerning precision, okay, and we've also talked about how we don't really know how to graph all sorts of rational expressions, so that might be another issue with this method, okay? So let's talk about how to graph or how to solve these algebraically. Okay, so we're going to start the exact same way that we started with the graphing method. We're going to move all terms to one side. Okay, and then something we didn't need to do with the graphing method, but we are going to do algebraically, is combine all terms into one term by making common denominators. Okay, it's really important that you do these two. The method won't actually work if you don't set it up correctly. Okay, so these two steps are super important. All right, So the third one is to factor numerator and denominator. Okay, and then just like the polynomial inequalities, we're going to make a sign chart. Okay, and then we're going to use that sign chart to write down our answer in interval notation. Okay, so here we go. Well, let's look at an example of this. Okay, so the first one we're going to look at x minus 3 over x plus 2 is greater than 0. Okay, so remember our first two steps were to move all of our terms to one side. We have that because our right side is 0. Okay, and then we want to combine all of the terms on the other side into a single fraction. Okay, well we have that. We have a single fraction here. Okay, then we're going to factor the numerator and denominator. These are already factored. Okay, and so now, because all of the setup is done, we're going to go ahead and make our sign chart. Okay, so we are going to make the sign chart using any zeros from the numerator and the zeros from the denominator. Okay, so in this example, there's going to be 2. Okay, from the denominator, we're going to have -2, and from the numerator, we're going to have +3. Okay, remember, you do need to put the zeros in order like they were on the number line, right? -2 is less, so it goes on the left. Okay, and then we're going to list all the factors, both from the numerator and the denominator, okay, over here on the side. Okay, and then just to remind you how to fill this out, you're testing a point from over here and seeing whether this factor is positive or negative. So if I plug in something like -3, -3 plus 2 is -1, so I would put a negative sign here. Okay, then here between -2 and 3, I could test something like 0. This will be positive, and this will be positive. Okay, and then I'm going to do the same up here. Testing a point from each section, I'll get negative, negative, positive. Okay, so now instead of looking at the product, we're going to look at Q, the quotient. Okay, so negative divided by negative is a positive. Negative divided by positive is negative. Positive divided by positive is positive. Okay, all right, now we're looking for greater than 0. Okay, so that's going to be the pluses. So we're going to start over here where it says off to -infinity, and then we're going to go up to -2. Okay, now here's where it's different than a polynomial function. Okay, well actually not in this example. Since it's strictly greater than, we're not going to include -2. Okay, then we're going to start at 3. Again, we're not going to include it because it's strictly greater than, and it goes off to infinity. Okay, and then we're going to combine them with the union. Okay, so very similar process to what we did with polynomials. Let's look at another example. Okay, so again, the first 3 steps are really taken care of for us. Everything's on the left. We have a single fraction. We don't need to combine anything. Okay, and everything is already factored for us. Okay, so we're going to start by making a sign chart, and we're going to list all the roots from the numerator and from the denominator. So I'm first just going to list them up here. Okay, so from the factor x, we would have 0. From the factor x plus 1, we'd have -1. Okay, then from down here, we would have 2 and -5. Okay, and then I'm going to put them here, okay, in increasing order, -5, -1, 0, and 2. Okay. And then I'm going to list each of my factors. Again, the ordering of the factors doesn't matter at all. Okay. And then I'm going to fill out the sign chart for each one. Okay, so 1, 2, 3, 4 negatives is a positive, 3 negatives is a negative, okay, 2 negatives is a positive, 1 negative, all positives. Okay, so now I'm going to be looking at where this is less than or equal to 0. Okay, so remember, okay, that's when we're looking at the negative signs. Okay, so I'm going to start at -5. Okay, and you might think that because I'm looking at or equal to, I would use a bracket to include that point. But looking at the original function, can I plug in -5? Well, I would have -5 plus 5, that's 0. I'd have 0 in the denominator. That's not allowed. Okay, so because of that, I'm going to put parentheses. Okay, and it's because -5 is not part of the domain of this function, it makes it undefined here. Okay, then I'm going to go up to -1. Okay, now if I look at my denominator, that's not going to make it 0 in the denominator, so I am going to include that point. Okay, then I'm going to start at 0. Again, not having any issues of making it undefined, so I'll include that point, and up to 2. And when you look at 2, 2 minus 2, that would be 0. That would be an issue. So I'm going to use parentheses there. Okay, and then I would combine these two using the union. All right, let's look at another example. All right. Okay, so in this example, you can see that we don't have everything on the left. So the first thing I'm going to do is subtract 2 from both sides. So I'm comparing the function to 0. Okay, and now you can see I have 2 separate terms here, right? Here's my main fraction, and then I have this extra 2. So I do need to combine these, and I'm going to do that by making common denominators. Okay, so now I'm going to subtract these. So x minus 2x is -x. Okay, and then minus -6, that's +6. Okay, and then I have my common denominator. Okay, so this is the actual inequality that I'm going to be using to make my sign chart. Okay, so my roots from the numerator are going to be 6, and my root from the denominator is going to be 3. Okay, so those are the 2 x values that I'm going to mark on my sign chart. Okay, and then I'm going to list my factors on the side, x minus 3, -x plus 6. Okay, I will ask you to be careful when you're plugging in things here. Okay, so like when you plug in 0, you would get 0 plus 6. Okay, so that's going to be positive. When you plug in something like 4, -4 plus 6, that's still positive. And then you plug in something like 7, -7 plus 6, that's -1. So we're going to get a negative here. Okay, so for some reason these negative x's make it a little bit harder to fill this out, so just be cautious of that as you're doing these problems. Okay, so positive divided by negative is negative. Positive divided by positive is positive. Negative divided by positive is negative. Okay. All right, so we want less than or equal to 0, so we're going to be looking at the negative signs. Okay, so we're going to start at negative infinity because this side points off, and up to 3. Okay, now we're going to look at this function. Are we allowed to plug in 3? No. Okay, so because of that, we'll put a parentheses. Then we're going to start at 6. Are we allowed to plug in 6? 6 minus 3, that's 3. Yes. Okay. And then off to infinity. And we'll combine them using the union. Okay. All right. Let's do another example like that. Okay. So again, the first thing I need to do is move everything to one side. Okay, and then I need to make common denominators so that I can add. So I'm going to multiply this by 2 over 2. Okay. And I'm going to multiply this fraction by x plus 1 over x plus 1. Okay, and now I'm going to subtract. So 2x minus x is negative 3x. Okay, and then 8 minus 1, that's 7. Over my common denominator. Okay, so let's look at my roots. Okay, so for the numerator, I think this is going to be 7/3. Okay, you're not always going to have integer roots. And then for the denominator, the only root is going to be negative 1. Okay, so let's mark those here. So negative 1 and then 7/3. Okay, so remember 7/3 is between 2 and 3. Okay, and then I'm going to list all of my factors, including this 2. So 2, x plus 1, negative 3, x plus 7. Okay, now 2 is always positive, right? 2 is a positive number, so I'm just going to put positive, positive, positive. Okay, students are sometimes confused about that, but it doesn't matter what x is, right? 2 is a positive value. Now, if this was negative 2, I would just put negative, negative, negative. Okay, all right. So for x plus 1, it's going to be negative, positive, positive. Okay, and I think this is going to be positive, positive, negative. All right. So 2 positives and a negative is negative, 3 positives is positive, 1 positive, or 1 negative, 2 positives is negative. All right. Now I want something that's greater than or equal to 0, so I'm going to be looking at the plus. Okay. So I'm going to start with negative 1. Now when I look at my denominator, that is a root from the denominator, so I can't include that value. It's not part of the domain. Okay, so I'm using parentheses to show that. And then I'm going to go up to 7/3, and I am going to include that because the function is defined there. All right. Let's look at one last example. Okay, so this is part C. All right, so the first thing I'm going to do is move everything to the left side. Okay, And then I'm going to make common denominators and try to add all three of these terms into a single fraction. Okay. All right. Now I'm going to go ahead and distribute in the numerator. Okay, and now I'm going to combine my like terms. So I have x squared, I have 2x plus 6x, that's 8x. Okay, and then I have 4 plus 12, that's 16, over my common denominator. All right. And now the next thing I'm going to do, and we haven't had to do this yet really, is I'm going to factor my numerator. Okay, so this is going to be x plus 4 times x plus 4 over x plus 2. Okay, and you could certainly rewrite this if you want to as x plus 4 squared over x plus 2. Okay, so if you remember, this would give you something, a root that's of multiplicity 2. Okay, so let me copy this over so that we can look at our sign chart. Okay, so here we go. My roots are going to be -4 and -2. Okay, so let me mark those on my sign chart. Okay. Okay, and we talked about this yesterday or in the previous video. Okay, but what happens when you have a squared factor, you can do two different things. You can do what I normally do, which is put x plus 4 squared, okay, or you can just do x plus 4 and then do x plus 4 again, okay? Both of those would work for your sign chart. Okay, so let me fill this out. I'm going to have negative, negative, positive, and when you have a square, right, this is always going to be positive. Okay, so for my quotient, I'm going to have positive divided by negative, that's negative. Again, positive divided by negative is negative. Positive divided by positive, that's a positive. Okay, all right. So now I want greater than or equal to 0. Okay, so I'm going to start here at -2. Okay, but when you look at this, x plus 2 in the denominator, I'm not allowed to plug in -2. So I'm going to use parentheses, and then it goes off to infinity. Okay, so that would be my final answer. All right, so I just wanted to emphasize for you guys that all the stuff we did at the beginning of this problem, where we moved everything to the left, use our rational function skills to combine them into a single term, is super important. There's no other way to do this, okay? You have to combine them together. So I just wanted to make sure that you guys understand that's not something that I prefer, that's a necessary step for this, okay? And I'll see you guys soon.